Our topic for today is the rules of exponents. What are exponents? Exponents are mathematical notation for repeated multiplication. We have 4 cubed or to the power 3 is this equals to 4 times 4 times 4 times 4. That is 3, 4. And this is equals to 16 times 4 is 64. That is 4 cubed. And 4 cube, 3 here is cube, and this is the exponent, while 4 here is the base. First rule, product rule. In multiplying the same base but different exponent, just copy the base and add the exponents. The formula here, a to the power m times a to the power n, the same base but different exponent, m and n, is equal to a to the power m plus n. So you add the exponent. 6 cubed times 6 to the fourth is equals to 6 to the power 3 plus 4, which is equals to 6 to the power 7. 3 plus 4 is 7. So you have here the power rule. When you raise a power to another power, multiply the exponents. For example, you have the formula here, a to the power m raised to the power n is equals to a to the power m times n. So for example, we have here 9 to the power 4 raised again to the power 3 is equals to 9 to the power 4 times 3, which is equals to 9 to the power 12. So quotient rule. In dividing the same base but different exponent, just copy the base and subtract the exponents. We have here a to the power m divided by a to the power n is equals to a to the power m minus n, provided that m is greater than n. There are certain conditions later on that we are going to discuss regarding this, because there are 3 situations that will occur in this quotient rule. So have here 9 to the power 4 divided by 9 squared is equals to 9 to the power 4 minus 2, and this is equals to 9 squared or equals to 81. That's the quotient rule. So we have here the negative exponent rule. A to the negative n is equals to 1 over n. This time n under the in the denominator, n in the denominator is positive, while at first is negative, then transfer it to its reciprocal, becomes a positive. So a negative exponent will result to its reciprocal, 1 over n. Example here, 9 to the power negative 2 is equals to 1 over 9 squared, which is equals to 1 over 81. Zero exponent rule. So a to the power 0, and any number raised to the power 0 is equals to 1. Even if it is 100, the power 0 is equals to 1. Even if it is 1 million, to the power 0, it is equals to 1. Later on we'll discuss why. So back to the quotient rule. If here a to the power m divided by a to the power n is equals to a to the power m is equals to a to the power m minus n, provided that m is greater than n. So we have the example previously, so happen second scenario that will happen here. N is greater than m. We have now 1 over a to the power n minus m. So this is now the new scenario when n is greater than m. Must be a negative that will happen if this, and this will result to its reciprocal. So another scenario here is when m is equals to n. So a to the power m divided by a to the power m is equals to a to the power m minus m, or this is equals to a to the power 0. And if you look at the other side, the left side, if you look at the left side, a to the power m divided by a to the power m is equals to the same base, the same power, or the same number is equals to 1. That's the explanation why a to the power 0 or any number raised to power 0 is equals to 1, because it is a number divided by itself, which is equals to 1. For example, we have 6 squared over 6 to the power 4 is equals to 6 to the power squared minus 4 power 2 minus 4 is equals to 6 to the power equals to 6 to the power negative 2. And any negative number is in the denominator. So we have here 1 over 6 squared, or 1 over 36, which is similar to into the denominator. Then this is equals to 6 to the power 4 minus 2, which is equals to 6 squared, and 6 squared is still 36. Then we have here 6 to the power 4 divided by 6 to the power 4 equals to 6 to the power 4 minus 4, which is equals to 6 to the power 0. And this is equals to, if you look at the left side, 6 to the power 4 divided by 6 to the power 4 is equals to 1. That's the explanation for power 0 and the negative power that is in the denominator.